BASIC is a family of general-purpose, high-level programming languages whose design philosophy emphasizes ease of use. In 1964, John G. Kemeny and Thomas E. Kurtz designed the original BASIC language at Dartmouth College in New Hampshire. They want to enable students in fields other than science and mathematics to use computers. At the time, nearly all use of computers required writing custom software, which was something only scientists and mathematicians tended to learn. Versions of BASIC became widespread on microcomputers in the mid-1970s and 1980s. Microcomputers usually shipped with BASIC, often in the machine's firmware. Having an easy-to-learn language on these early personal computers allowed small business owners, professionals, hobbyists, and consultants to develop custom software on computers they could afford. BASIC remains popular in many dialects and in new languages influenced by BASIC, such as Microsoft's Visual Basic. In 2006, 59% of developers for the .NET framework used Visual Basic .NET as their only programming language. History: before the mid-1960s, computers were extremely expensive mainframe machines, usually requiring a dedicated computer room and air conditioning, used by large organizations for scientific and commercial tasks. Users submitted jobs, on punched cards or similar media, to computer operators, and usually collected the output later. A simple batch processing arrangement ran only a single job at a time, one after another. During the 1960s, faster and more affordable computers, still mainframes, became available, and time sharing, a technique which allows multiple users or processes to share use of the CPU and memory, was developed. In such a system, the operating system gives each of several processes time on the CPU, then pauses it and switches to another. Each process behaves as if it had full use of the computer, although the time to complete its operation increases. Time sharing was initially used to allow several batched processes to execute simultaneously. Time sharing also allowed several independent users to interact with the computer, working on terminals with keyboards and teletype printers, and later display screens. Computers were fast enough to respond quickly to each user. The need to optimize interactive time sharing, using command line interpreters in programming languages, was an area of intense research during the 1960s and 1970s. Origin: the original BASIC language was designed on May 1, 1964 by John Kemeny and Thomas Kurtz and implemented by a team of Dartmouth students under their direction. The acronym BASIC comes from the name of an unpublished paper by Thomas Kurtz. BASIC was designed to allow students to write mainframe computer programs for the Dartmouth time-sharing system. It was intended specifically for less technical users who did not have or want the mathematical background previously expected. Being able to use a computer to support teaching and research was quite novel at the time. The language was based on Fortran 2, with some influences from ALGOL 60 and with additions to make it suitable for time sharing. Initially, BASIC concentrated on supporting straightforward mathematical work, with matrix arithmetic support from its initial implementation as a batch language, and character string functionality being added by 1965. The designers of the language decided to make the compiler available free of charge so that the language would become widespread. They also made it available to high schools in the Hanover area, and put a considerable amount of effort into promoting the language. In the following years, as other dialects of BASIC appeared, Kemeny and Kurtz's original BASIC dialect became known as Dartmouth Basic, spread on mini-computers. Knowledge of the relatively simple BASIC became widespread for a computer language, and it was implemented by a number of manufacturers, becoming fairly popular on newer mini-computers such as the DECP-DP series and the Data General Nova. The BASIC language was also central to the HP time-shared BASIC system in the late 1960s and early 1970s, where the language was implemented as an interpreter. Also at this time it was ported into the PIC operating system where a compiler renders it into pseudo-instruction code, able to be interpreted by a virtual machine. During this period a number of simple computer games were written in BASIC, most notably Mike Mayfield's Star Trek. A number of these were collected by DEC employee David H. Earl and published in a newsletter he compiled. He later collected a number of these into book form, 101 Basic Computer Games, which was first published in 1973. During the same period, Earl was involved in the creation of a small computer for education use, an early personal computer. When management refused to support the concept, Earl left DEC in 1974 to found the seminal computer magazine, Creative Computing. The book remained popular, and was republished on several occasions. Explosive Growth, the Home Computer Era. The introduction of the first microcomputers in the mid-1970s was the start of explosive growth for BASIC. It had the advantage that it was fairly well known to the young designers and computer hobbyists who took an interest in microcomputers. One of the first to appear was Tiny Basic, a simple BASIC variant designed by Dennis Allison at the urging of Bob Albrecht of the Homebrew Computer Club. He had seen BASIC on mini-computers and felt it would be the perfect match for new machines like the MIT's Altair 8800. How to design and implement a stripped-down version of an interpreter for the BASIC language was covered in articles by Allison in the first 3 quarterly issues of the People's Computer Company newsletter published in 1975 and implementations with source code published in Dr. Dobbs' Journal of Tiny Basic Calisthenics and Orthodontia, Running Light Without Overbite. Versions were written by Lee Chen Wang and Tom Pittman. In 1975 MIT's released Altair Basic, developed by Bill Gates and Paul Allen as the company Microsoft, which eventually grew into corporate giant Microsoft. The first Altair version was co-written by Gates, Allen, and Monty Davidoff. When the Apple II, PET 2001 and TRS-80 were all released in 1977, all 3 had BASIC as their primary programming language and operating environment. Upon boot, a BASIC interpreter in immediate mode was presented, not the command line interface used later. Commodore business machines included a version of Microsoft BASIC. The Apple II and TRS-80 each had 2 versions of BASIC, a smaller introductory version introduced with the initial releases of the machines and a more advanced version developed as interest in the platforms increased. As new companies entered the field, additional versions were added that subtly changed the BASIC family. The Atari 8-bit family had their own Atari BASIC that was modified in order to fit on an 8 KB ROM cartridge. The BBC published BBC BASIC, developed for them by Acorn Computers Limited, incorporating many extra structuring keywords and advanced floating-point operation features. Almost universally, home computers of the 1980s had a ROM-resident BASIC interpreter, allowing the machines to boot directly into BASIC, which therefore constituted a significant and visible part of the user interface of many home computers' rudimentary operating systems. As the popularity of BASIC grew in this period, magazines published complete source code in BASIC for games, utilities, and other programs. Given BASIC's straightforward nature, it was a simple matter to type in the code from the magazine and execute the program. Different magazines were published featuring programs for specific computers, though some BASIC programs were considered universal and could be used in machines running any variant of BASIC. Many books of type-in programs were also available, and in particular, Earl published versions of the original 101 BASIC games converted into the Microsoft Dialect and published it from Creative Computing as Basic Computer Games. This book, and its sequels, provided hundreds of ready-to-go programs that could be easily converted to practically any BASIC running platform. The book reached stores in 1978, just as the home computer market was starting off, and it became the first million-selling computer book. Later packages, such as Learn to Program BASIC, would also have gaming as an introductory focus. On the business-focused CP/M computers, which soon became widespread in small business environments, Microsoft BASIC was one of the leading applications. IBM PC, and compatibles. When IBM was designing the IBM PC, they followed the paradigm of existing home computers in wanting to have a built-in BASIC. They sourced this from Microsoft, IBM Cassette BASIC, but Microsoft also produced several other versions of BASIC for MS-DOS PC DOS, including IBM Disk BASIC, IBM Basica, GW BASIC and Quick BASIC, all typically bundled with the machine. In addition, they produced the Microsoft BASIC compiler aimed at professional programmers. Turbo Pascal publisher Borland published Turbo BASIC 1.0 in 1985. Microsoft wrote the windowing-based Amiga BASIC that was supplied with version 1.1 of the preemptive multitasking GUI Amiga computers, although the product unusually did not bear any Microsoft marks. These languages introduced many extensions to the original home computer BASIC, such as improved string manipulation and graphics support, access to the file system and additional data types. More important were the facilities for structured programming, including additional control structures and proper subroutines supporting local variables. However, by the latter half of the 1980s, users were increasingly using applications written by others, rather than learning programming themselves, while professional programmers now had a wide range of more advanced languages available, and BASIC tended to become the butt of derogatory comments such as Dijkstra's famous comment, "It is practically impossible to teach good programming to students that have had a prior exposure to BASIC, as potential programmers they are mentally mutilated beyond hope of regeneration." Visual BASIC, BASIC's fortunes reversed once again with the introduction in 1991 of Visual BASIC, by Microsoft. This was an evolutionary development of Quick BASIC, and included constructs from other languages such as block-structured control statements including with and for each, parameterized subroutines, optional static typing, and more recently a full object-oriented language. But the language retains considerable links to its past, such as the dim statement for declarations, subreturn statements, and even line numbers, which are still needed to report errors properly. An important driver for the development of Visual BASIC was as the new macro language for Excel. Ironically, given the origin of BASIC as a beginner's language, and apparently even to the surprise of many at Microsoft who still initially marketed it as a language for hobbyists, the language had come into widespread use for small custom business applications shortly after the release of VB version 3.0, which is widely considered the first relatively stable version. While many advanced programmers still scoffed at its use, VB met the needs of small businesses efficiently wherever processing speed was less of a concern than ease of development. By that time, computers running Windows 3.1 had become fast enough that many business-related processes could be completed in the blink of an eye, even using a slow language, as long as large amounts of data were not involved. Many small business owners found they could create their own small, yet useful applications in a few evenings to meet their own specialized needs. Eventually, during the lengthy lifetime of VB3, knowledge of Visual BASIC had become a marketable job skill. Microsoft also produced VBScript in 1996 and Visual Basic.net in 2001. The latter has essentially the same power as C and Java, but with syntax that reflects the original BASIC language. Recent versions, many other BASIC dialects have also sprung up since 1990, including the open-source QB64, Bywater BASIC, Gambas and Free BASIC, and the commercial Pure BASIC, Power BASIC, Real BASIC, and True BASIC. Several web-based Simple BASIC interpreters also now exist, including Quite BASIC and Microsoft's Small BASIC. Versions of BASIC have been showing up for use on smartphones and tablets. Apple App Store contains such implementations of BASIC programming language as Smart BASIC, BASIC, Hotpool BASIC, BASIC II, Tech BASIC and others. Android devices feature such implementations of BASIC as RFO BASIC and Mentores BASIC. Applications for some mobile computers with proprietary OS can be built with programming environment based on BASIC. An application for the Nintendo 3DS and Nintendo DSi called Petty Computer allows for programming in a slightly modified version of BASIC with DSi button support. Nostalgia. The ubiquity of BASIC interpreters on personal computers was such that textbooks once included simple try-it-in-BASIC exercises that encouraged students to experiment with mathematical and computational concepts on classroom or home computers. Popular computer magazines of the day typically included type-in programs. Futurist and sci-fi writer David Brin mourned the loss of ubiquitous BASIC in a 2006 Salon article, as have others who first used computers during this era. In turn, The article prompted Microsoft to develop and release Small Basic. Syntax, typical basic keywords, data manipulation, LET, assigns a value to a variable. Data, holds a list of values which are assigned sequentially using the read command. Program flow control, IF. Then, else, used to perform comparisons or make decisions. FOR. TO. Step. Next, repeat a section of code a given number of times. A variable that acts as a counter is available within the loop. While, WEND and repeat. Until, repeat a section of code while the specified condition is true. The condition may be evaluated before each iteration of the loop, or after. Do, loop while or until repeat a section of code forever or while until the specified condition is true. The condition may be evaluated before each iteration of the loop, or after. GOTO, jumps to a numbered or labeled line in the program. GOSUB, jumps to a numbered or labeled line, executes the code it finds there until it reaches a return command, on which it jumps back to the operator following the GOSUB, either after a colon, or on the next line. This is used to implement subroutines. ON. Go to GOSUB, chooses where to jump based on the specified conditions. See switch statement for other forms. DEFFN, a pair of keywords introduced in the early 1960s to define functions. The original basic functions were modeled on Fortran single-line functions. Basic functions were one expression with variable arguments, rather than subroutines, with a syntax on the model of DEFFND, x equals XX at the beginning of a program. Function names were originally restricted to FN plus one letter. Input and output, print, displays a message on the screen or other output device. Input, asks the user to enter the value of a variable. The statement may include a prompt message. TAB or AT, sets the position where the next character will be shown on the screen or printed on paper. Miscellaneous, REM, holds a programmer's comment or remark. Often used to give a title to the program and to help identify the purpose of a given section of code. USR, transfers program control to a machine language subroutine, usually entered as an alphanumeric string or in a list of data statements. TRON, turns on a visual, screen representation of the flow of basic commands by displaying the number of each command line as it is run. The TRON command, largely obsolete now, stood for trace ON. This meant that command line numbers were displayed as the program ran, so that the command lines could be traced. This command allowed easier debugging or correcting of command lines that caused problems in a program. Problems included a program terminating without providing a desired result, a program providing an obviously erroneous result, a program running in a non-terminating loop, or a program otherwise having a non-obvious error. TROFF, turns off the display of the number of each command line as command lines run after the command TRON has been used. Data types and variables, minimal versions of BASIC had only integer variables and one or two letter variable names, which minimized requirements of limited and expensive memory. More powerful versions had floating point arithmetic, and variables could be labeled with names 6 or more characters long. There were some problems and restrictions in early implementations. For example, AppleSoft allowed variable names to be several characters long, but only the first two were significant, thus it was possible to inadvertently write a program with variables loss and loan, which would be treated as being the same. Assigning a value to loan would silently overwrite the value intended as loss. Keywords could not be used in variables in many early BASICs. Score would be interpreted as SC, or E, where R was a keyword. String variables are usually distinguished in many microcomputer dialects by having $ suffix to their name, and values are often identified as strings by being delimited by double quotation marks. Arrays in BASIC could contain integers, floating point or string variables. Some dialects of BASIC supported matrices and matrix operations, useful for the solution of sets of simultaneous linear algebraic equations. These dialects would directly support matrix operations such as assignment, addition, multiplication, and evaluation of a determinant. Many microcomputer basics did not support this data type. Matrix operations were still possible, but had to be programmed explicitly on array elements. Examples: the original Dartmouth BASIC was unusual in having a matrix keyword, MAT. Although dropped by most later microprocessor derivatives, it is used in this example from the 1968 manual, which averages the numbers that are input. New BASIC programmers on a home computer might start with a simple program, perhaps using the language's print statement to display a message on the screen. A well-known and often replicated example is Kemeny and Ritchie's Hello World program. An infinite loop could be used to fill the display with the message. Most first-generation BASIC versions such as MSX BASIC and GW BASIC supported simple data types, loop cycles and arrays. The following example is written for GW BASIC, but will work in most versions of BASIC with minimal changes. The resulting dialogue might resemble: "What is your name, Mike? Hello Mike, how many stars do you want? 7. Do you want more stars? Yes, how many stars do you want? 3. Do you want more stars? No, goodbye Mike." Second-generation BASICs introduced a number of features into the language, primarily related to structured and procedure-oriented programming. Usually, line numbering is omitted from the language and replaced with labels and procedures to encourage easier and more flexible design. Third-generation BASIC dialects such as Visual BASIC, Real BASIC, Star Office BASIC and Blitz Max introduced features to support object-oriented and event-driven programming paradigm. Most built-in procedures and functions are now represented as methods of standard objects rather than operators. The following example is in Visual Basic.NET. Standards: ANSI standard for Minimal Basic, ANSIX 3.60-1978 for Minimal Basic, ISO IEC 6373-1984 Data Processing Euro Programming Language ESA Euro Minimal Basic. ECMA 55 Minimal Basic, ANSI standard for Full Basic, ANSIX 3.113-1987 Programming Languages Full Basic, INSITEC 10279-1991 Information Technology, Programming Languages, Full Basic. ANSI Addendum Defining Modules, ANSIX 3.113 Interpretations 1992 Basic Technical Information Bulletin No. 1 Interpretations of ANSIO 3.113-1987, ISO IEC 10279-1991/and 1994 Modules and Single Character Input Enhancement. ECMA 116 Basic, see also, List of Basic Dialects, References, Notes. Citations. Bibliography. External links, Basic at DMOZ.